In this lesson, we will be discussing groundwater. But before we start talking about groundwater, I want to discuss the hydrologic cycle. The hydrologic cycle describes how water moves on the surface of Earth. Start by looking at water evaporating from the oceans. That evaporated water will eventually form clouds. When the clouds become oversaturated, it will start precipitating, either raining or snowing, and the water falls back to the surface of Earth. That water will either run over the surface as runoff or infiltrate into the ground and become part of the groundwater system. Eventually, the water will make its way back to the oceans, or along the way it will be evaporated again into the clouds, continuing the cycle. Now let's look at the different reservoirs of water of the hydrologic cycle. The oceans are by far the largest reservoir, containing approximately 90% of all water on Earth. Glaciers and ice sheets are the next largest reservoir, containing approximately 2% of all the water on Earth. Now, groundwater is the third largest water resource, containing approximately 0.5% of all the water on Earth. Freshwater lakes, saline lakes, rivers and streams, like the one you see behind me, make up a very small percentage of water on Earth. If you consider the three largest reservoirs of water, oceans are too salty to drink or use for agriculture use. The water trapped in glaciers and ice are frozen and therefore cannot be used. Therefore, groundwater is the largest usable source of fresh water. As it is the largest usable freshwater source on Earth, it is important to understand the concept of groundwater. Simply put, groundwater is the water that exists in the pore spaces of rocks and sediments underground. In this lesson, you're going to learn about the saturated zone, where all of the pore spaces are filled with water, and the unsaturated zone, where only some of the pore spaces are filled with water and others are filled with air. The boundary between the two zones is called the water table. In this lesson, you will not only create small aquifer models, but you will also map the water table in a region in Pennsylvania and determine how long it takes for the groundwater to flow from one location to another.